So today's lesson is going to start to move to not just the solving questions like find this angle or questions like we did before, but we're going to start to talk about how do we prove a quadrilateral is cyclic, or how do we prove something is a tangent, or how do we prove something is a diameter. And what that is going to use is the converse theorems. And we're not going to only do those, we're going to mix stuff together, but you're going to start to see what we call the converse theorems, which we generally use to prove something is a cyclic quad, a tangent, or a diameter. But before I start with that, let's just have a look at what a cyclic quad is. A cyclic quad is a quad where a circle can go through all 4 points. So that would be a cyclic quad. Now, this over here, PQRS, that's a cyclic quad. Over here, that's not a cyclic quad because a circle can't go through all 4 points. And this is also not a cyclic quad because this 4th point can't be the middle. It would have to be out here. Now, that is just a visual example of cyclic quads. But when we go to the theorems that deal with how we prove something is a cyclic quad, there are 3 ways we can prove something is a cyclic quad. If the opposite angles are supplementary, then we know it's a cyclic quad. So sometimes the way they show this in like textbooks is they'll say, well, this and this side, these 2 sides have to add up to 180, or those 2 would add up to 180. The other way of proving something is a cyclic quad is if the exterior angle equals the interior opposite. So if you have a quadrilateral and you have an exterior angle, if the exterior angle is equal to the interior opposite, then we know that it's a cyclic quad, that we can fit a circle through those 4 points. And then the last one for proving something's a cyclic quad is if a line segment subtends an equal angle on the same side. Now that sounds like a mouthful, but basically here's a line segment. If this line segment makes an angle up here, and that same line segment makes an angle up there, if they make 2 angles that are the same, okay, then we know these 4 points will form a cyclic quad. So let me actually even do this here. So these are the 3 converse. So this one over here would be converse opposite angles supplementary, because you're showing the opposite angles are supplementary, therefore it's a cyclic quad. Then for this one, it's going to be converse exterior angle cyclic quad. And I'll give you a summary later. This is me just showing it. And this also shows if you show the exterior angle equals the interior opposite, you've got a cyclic. And this is going to be called converse angles in same segment. So these are the 3 ways that we're looking out for to check. Can we use one of these ways to prove something, the quadrilateral is cyclic? Give me a thumbs up if the basic idea makes sense. Obviously, we have to make use of it, but give me a thumbs up if that basic idea is at least like, you're like, oh, okay, I get it. This is like going in the opposite direction, or the converse theorem. Okay, now I'm going to focus more on converse of cyclic quads tonight, but you can also use the converse of the tangent theorems to prove that something is a tangent. In fact, I'll come back to that later. So all I'm saying is, if you want to prove something is a cyclic quad, you look and see, are the opposite angles supplementary? Do opposite angles add up to 180? If they do, it's a cyclic quad. Or you can check, is the exterior angle of a quadrilateral equal to the interior opposite? Then it's a cyclic quad. Or look if there's a line segment that subtends 2 equal angles. And then you've also another way of proving it's a cyclic quad. Now, I don't want to talk too long. I want to actually show you examples, and that will make more sense. But I also want to mix in old questions, because you need to be able to do the old stuff and then bring in the new. So we're going to get going today just with a normal circle geometry question from like an exam. And I want you to find for me, I want you to, give me a second. I want you to find for me the value of, let's do this one. Find me the value of A, B, C, and X and Y. So I want you to find the value of A, B, C, and also X and Y. And I want you to provide reasons for that. So you're given the circle, and I want you to find me the value of A, B, C, X, and Y. And off we go. So that would be A, that would be B, that would be C, that would be X, and let's say that would be Y. So Mzwandile has said that A is 10, and I agree. And the reason A is 10 is either we would say radii, or we could, yeah, in fact, we have to say radii because this comes from the center and this comes from the center. Now, what do we think B is going to be? Put your answers in the chat for B and for Y and also all those things. So I think we have to try, what do we know for sure here? Well, we know that X is 35. And the reason we know that X is 35 is also radii, or we can say angles opposite equal sides. So we know that this is opposite. Wait. We know those are equal sides. Oh, that's an isosceles triangle. The opposite angles opposite equal sides. And so that's why, yes, so that's 35. If we know X is 35, well, then we know that Y must be 90. And the reason it must be 90 is all the angles in a triangle add up to 90. So we'll say the sum of angles in triangle. So this one over here will be 90. We can't actually find what B and C are until we've done X and Y, which is a little bit confusing, but I just want to make sure that you are, if you imagine like this side over here points to that one, and that side over there points to that one. And then you know this is 55, and you know that's 35, and together that gives you 90, which means Y must be 90. Give me a thumbs up if you understand how I've got A, X, and Y. Thumbs down if you're feeling confused. Okay. Awam, we can't say Y is 90 because we don't know the size. We actually don't know. We don't know what the size of B is yet. So there is a theorem that deals with this, but we don't have enough information until we get the X and the Y value. Now that we know that this is 90, we can say that B is 4. And the theorem that we use is we say line from center perpendicular to chord. And so we use the fact that this is 90 to say why that to or line from center perpendicular to chord. And we know that it cuts these two in half. Now, how are we going to find C, which is the last step? So C is actually a length. C is this thing over here. So sorry, C is the little c is what I'm looking for. What theorem are we going to use for that? Okay, yes, we're going to use Pythagoras. So we know that's 4 and that's 10. So what do we get for this bit over here? Yes, Buchle, I like it. Gracia, you are correct. Let's do it, Segavatso. I think we know 10 squared equals 4 squared plus c squared by Pythag. And then I'm just going to take my working out down here. And so you guys are going to have to help me with a calculator. C is going to be the square root of 100 minus 16, which, okay, if we round off to 1 decimal place, will be 10.8 units. No, it can't be 10.8. That's a lie, because it has to be less. Think about this. It's 100 minus 16. So be careful. It's going to have to be less than 10, because it's 100 minus 16. So what are we going to get? We're going to get 9.17. Yeah. Okay, so it's a nice way that we need to start to get to know the theorems well, but it's a nice question to just get the juices flowing again. Nicely done, Brooklyn. Give me a thumbs up if you're feeling okay. Give me a thumbs down if you're feeling a bit lost. Just want to get a feel for the room. Okay, now remember, for those who are feeling a bit left behind, you can come back and see the recording. Okay, so it's not a case of, this is your only chance. You can definitely come back and see the recording. Let's try another question over here. So in this question, you have to find X, Y, and Z, and then we're going to move on to one with some of the new stuff mixed in. But let's just see if we can find X, Y, and Z. And you have to give me some of the reasons as well. Ooh, careful, everyone. Careful, careful. Angle at the center. So let's say you have this chord. And then watch out. Careful, careful, careful. I know it's sneaky. This is a sneaky one, Morgan. It's a sneaky one. Ask yourself, what theorem does this remind me of? So I want to say that the arc VY is the arc that is subtending an angle, and it's subtending the angle at the center, and it's subtending the angle where else? So Kwanda, you're right for Y, you're on the right track, but let's just make sure so we're going to get to Y in a moment, but what is X going to be? X is not going to be 80. It's going to be something a little bit different. You're on the right track, Feliciwa, but not quite. Aha, the angle at the center is twice the angle at the circumference. So and you can kind of see this, doesn't this one look like a bigger angle than that one? That one looks like a little tiny angle, and this one looks a bit bigger. X is going to be 40 degrees, and the reason is going to be angle at center is twice angle at circumference. And so this is going to be 40 degrees. Well, let me put this in a darker color. Okay, so that is going to be 40 degrees. So watch out for the shape. Whenever you have, remember, if you have an arc like this and it makes an angle here at the center, it can, that same arc can make an angle at the circumference. And even though it looks like the butterfly, it's not the butterfly, because the real butterfly has to have both of the angles formed at the circumference. So there's the one, and then it can form. Okay, now there's a difference between those two. And that's obviously why you're here. You're learning about that. But be aware of that. What is Y going to be? We already had this a little bit earlier in the chat stream, but what do we think Y is going to be?
80 degrees.
Perfect. What's your reason going to be?
Isn't it alternating angles?
Yeah, perfect. Absolutely perfect. So Y is 80, and we can see that relationship between that and that, there's the line. So we go alternate angles, and we have OV parallel to XY. Perfect. Thanks. I'll give you some time to try and figure out what Z is. What do we think Z is? Bit of a sneaky one. Okay. So I'm going to take away some of my lines just so you can see a bit more. And it's very sneaky, because what is XVZY? What is XVZY in the terminology or the language of circles? What type of quadrilateral is that? It's a quad. Yes, it's a quad. And what type of quad is it? It's actually, it's not necessarily a trapeze. It's the yellow thing I want you to look at. Look at the yellow thing. What is special about it? Ah, Kumo, you are on the money. Look at these points. There's one, there's one, there's one. And it's, even though it's like a squashed down cyclic quad, but if you think of the definition, V, or X, Y, Z, V is a cyclic quad. So what do we know about the relationship for Z? What is Z going to have to be? What relationship does Z have with something else? Okay, now here's the sneaky bit. If you look at this angle over here and this angle over here, would you agree that they are opposite angles in a cyclic quad? Now, you know that opposite angles in a cyclic quad add up to 140, well, 180, sorry. So that has to be 140. What does this one on the outside then need to be? What does Z have to be? So Z, because of angles on a straight line, you would say Z is 40. Yes. Another way of saying this is to say Z is 40 because it's the exterior angle of a cyclic quad. Now, it's a very weird cyclic quad, but think about this line. This line goes straight. So this is an exterior angle. Here's the interior angle. What's opposite this 140? It's that one up there. That's why those are in relationship. And so we say that Z is 40. Okay. Now that was a little bit more tricky, but again, we're starting to build our circle geometry stamina. Are there any questions about that one? Now that I've outlined it a bit, can you sort of see the yellow cyclic quadrilateral? Give me a thumbs up if you can see the yellow cyclic quad. And give me a thumbs down if you're feeling a bit lost and confused. Okay. Okay. And be honest, it's fine. Just to give me some feedback. Okay, before we have our break, I just want to set up the next question, and then we'll come back after the break in terms of how the question is going to work. So let's leave that one out for now. Okay, so if we look at where we're coming back to after the break, let's have a quick look at another exam question or type of exam question. If you look at the first part of this question, you're given a circle geometry diagram and you asked a whole bunch of questions about the angles, which is the types of things we've been doing so far. But then the next part asks you, is TOPM a cyclic quadrilateral? And so that's the new type of question that we're going to be learning about in the second half of the lesson. Okay, so just to set up for after the break, but we've done a solid half an hour. So what I want is everyone on their feet. I want you to turn on your cameras, and I just want you to stand up with me and give your brain a break. And let's see those happy faces. Happy that you're getting a break. There we go. Oh, it's so nice. I can see so many students. Okay, let's do this. All right. So just stand up straight and let's take a nice deep breath. And breathe out. A nice deep breath. Another deep breath. Okay, shake out the arms, get nice and loose, shake out the legs, get some circulation going in your body, feel like a human being. Let us just do a little bit of rotating around, nice and loose around the hips, and as you relax, you'll turn some more. There we go. I can feel myself relaxing. Okay, let's do a stretch across here. And then let's switch to the other side. Oh, this feels good. And let's do a tricep stretch. There we go. And let's do the other side as well. Oh, I can feel my neck is so tight. Okay, and then let's shake it out. And I feel like today is an overachiever day, so we're going to do jumping jacks. So we're going to do 20 jumping jacks. You know how these work, like this. And we're going to do 20 in 3, 2, 1. Let's go. 2. Halfway. And we are done. Okay. Do you feel alive? Do you feel alive? And let's just do a little Maths 24 just to indulge ourselves. So the way Maths 24 works for those who are new is that you try and make 24 with all the numbers on the card. You must use each number and only use it once to see if you can do it.
Please repeat the question, say.
So what we need to do is we need to try and make 24 using these numbers. And it's just a little game we play to unwind a little bit. So for example, I see Miguel has said 8 minus 5. Now 8 minus 5 is 3. And so we've used up 2 of the numbers. Now, how can we get to 24 using the last 2 numbers on the card? is kind of where we're going. And I see in the chat some ideas are coming through. The idea has been put forward that we add 7 and 1 to get 8. And so we've used up all the numbers, and all we need to do to get 24 is times 3 by 8. So we've used all the numbers and we've got to 24. So I see Morgan and Mole Mashile and Miguel have all given us that one. See if you can have a go at the blue one, and there can be more than one way to do things. So if you, yeah, I'll give you another minute or so, and then we'll return to our, the work we were doing. So, Feliciwa, you're close. Oh, you're more than close. I think you might have got there. So, Feliciwa has said 5 times 3 is 15. And Mbali and Zanele agree. They say, well, and once you've got 15, you just add 8 and you add 1, and you get 23, and then plus 1 is 24. Because you've just added, basically you get the 9, and then you get that. And Keisha has even, oh, Keisha's got an even very sneaky way. 8 minus 3 is 5. 5 times 5 is 25, and then take away 1 gives you 24. So Keisha, I hear you and I see you. That is awesome. Okay, before we get too far down the Maths 24 rabbit hole, let's go back to circle geometry, but well done, everyone. I can see your Maths 24 skills improving. Let's try and do A, B, C, and D first. So this would be 8 marks in an exam. And typically these find angles equal or find other angles equal to X questions come first. So see if you can find me T1 and see if you can do the, just keep trying to do these ones and I will give hints, or if there's questions, raise your hand and we will have a go at this one. Okay. So over to you guys. See what you can do. Can you get 2.1 and put your answers in the chat, or raise your hand and you can give me some feedback? So what have we got so far? Oh, wow. Yes, Morgan. T1 and T2 equals 90, line from set. Well done. Yes, you're on the right track. Into Corso, I think you're also on the right track. Oh, you guys, yep. Just keep doing all 4 of those first ones. And when you've done A, B, C, D, just say done in the chat. Remember, though, that you need to do not just the answer, you also need to write down the reason for yourself. So Morgan has given us a good tip that for T1 and T2, a good thing to look at is that this thing over here, this whisker over here, the green one, seems to be equal to the pink one. Because of these, okay, that looks a bit like a crime scene, but you get these 2 little equal length things going on here. So this one over here, because there's a line from the center to the midpoint of the chord, T1 must be 90. So that's the first let me even get rid of some of the stuff, so it's a bit too overwhelming. So we know that this one over here and this one over here will be 90. Now, O2 is the angle at the center, and this is the angle at the circumference. Now, the angle at the center is double the angle at the circumference from the same chord, and so O2 is actually going to be 100. And that, let me make it a little bit, let me zoom in, because otherwise it's a bit. So 100, and then we'll say angle at center equals twice angle at circumference. So this one over here is actually 100. I'll give you a bit more time to get S and P1. So Koki, I agree with you. And Koki has said that S is 50 degrees. And what I see for S is that it's the butterfly. It's a little bit hidden, but if you imagine that that one over there normally the butterfly's wings are roughly equal, but in this case, you can kind of see that this relationship here and this one here, S is going to be 50. And the reason we should use is angles in same segment. And so that would be 50. Okay, last one, P1. What is P1 going to be? There are two butterflies. There are two butterflies, but you must be careful. In order to be a real butterfly, you have to make sure that the points are on the circumference of the circle. So which butterfly are you talking about? Because the one that includes O is actually going to be the angle. Oh, you're right. So what you could say is that the angle at the center, which is 100, the one at the circumference has to be half. And so if you halve 100, you get 50. So you could have used angle at center is twice angle at circumference, or angles in same segment to get these two to be 50. Yeah, Lishan, yeah, exactly. So it just depends on what reason you use. You could have used another reason here. And that's often how it is in geometry. It's not like there's just one way, as long as you're clear though. Now, what about P1? How am I going to get that? Can you give us a tip, Morgan, as to what fact you used to get what P1 was? Sum of angles. Okay, awesome. And what else? You write sum of angles, but there was one extra thing you used. So I think Morgan is wanting us to focus on this triangle down here. And I agree that the yellow triangle has to add up to 180. But what other piece of information do I use to know that P1 is 40, like Morgan is saying? Who feels like they can crack the case here? There's a mystery piece of evidence that's been left out. So I think these are both radii. Yes, Buchle, absolutely. So we say P1 is 40, and we actually have to put two reasons here, radii and sum of angles in triangles. Sorry for my writing, guys. It's a lot to squeeze into a space. So we first know that these two must be equal because of radii, and therefore we know that these must each be 40. Why is P1 40? So Zwandile, do you get that if we know this one over here is 100, and we know these two, OM and OP, are equal because of radii, then we know that these two angles, because they're opposite equal sides, they have to be the same size. right? So that's why they have to be that. Okay, here's the big question. Is TOPM a cyclic quadrilateral? Give a reason for your answer. Is TOPM a cyclic quadrilateral? How would we know that? What would we want to check? Okay, you're right. So they don't all touch the circle. That's true. But remember, it might be possible that a circle could be drawn, another circle could be drawn through those points. Now, what do we want to check? So you're right, it won't fit through this circle, but we've got to figure out whether or not it goes through another circle could fit through it. So let's actually look at which TOPM, TOPM. Okay, now, what are in TOPM? Can you notice that we have two opposite angles? And I'm sorry that I'm making this so like it looks like a crime scene, but if you look at the angle T1, do you know what T1 is? T1 in our green cyclic quad? Yes. What is T1 equal to? It's equal to 90. What is P1 equal to? P1 is equal to 40. Why does that tell us that this cannot be a cyclic quad? Why do we know? Okay, because they're not exactly. So T1 plus P1 equal 130. So not cyclic quad as opposite angles not equal 180. So if something was a cyclic quad, the opposite angles would add to 180. Because these add to 130, it can't be a cyclic quad. I just want to make this point super clear. It is sometimes it's possible if the opposite angles added up to 180, then it would be possible to fit a circle through these 4 points. The fact that it doesn't, you can clearly see that that green one can't fit on the circle over here, but there are other circles in the universe. So what you need to check for are those 3 things that I mentioned at the beginning. Either the opposite angles add up to 180 or they don't. The exterior angle is equal to the interior opposite. So you can see here the exterior angle would be T2, and that's definitely not equal to P1. Or you could look for the angles in the same segment converse, but that's harder here. If you understand why the green quadrilateral is not a cyclic quad, give me a thumbs up and give me a thumbs down if I've lost you. Okay, awesome. Let's see if we can squeeze in one more if there's time today. Take a screenshot if you want from here, but maybe we can squeeze in one more if there's time. Okay, we're not going to finish this completely, but we're just going to start it and we'll carry on in the next lesson. So here is your question. Now, I haven't got all of you yet. Don't worry. We're going to carry on with this type of question on Wednesday. But let's just start by doing 3.1 and then we'll go from there. So 3.1 says, in the diagram, PSRM is a circle. That's an S up here with center O, and MOS, so MOS, which is this one here, is 2x. Give with reasons 3 other angles equal to x. So see if you can find me 3 other angles equal to x in this drawing. And if you feel generous, give us some tips in the chat to help us along. How would M2 work? So what are you thinking with M2? How do you justify M2? We know this one is 2x, right? Okay, not a bad idea, but if they were alternate angles, they would have to be those arrows, right? Unfortunately, they don't mention any tangents here. So I'm going to give you a little tip. What if this chord was quite important? What if the chord MS was quite important? What angle does the chord MS make at the center? I think the chord MS makes the angle 2x at the center, but it makes the angle P1 at the circumference. So my thinking was, what does P1 have to be? What does P1 have to be? Okay, P1 is not going to be 2x. Think about the theorem. So imagine you make an angle at the center, right? So you're using the lime or the Lumo green, and you make this angle at the center, but now you use that same base and you make an angle at the circumference. What's P1 going to be equal to? P1 is actually going to be equal to x. And the reason is going to be angle at center is twice angle at circumference. Yes, Kumo, yes. So we know, even though it's squeezed up a little bit, we can clearly see that this is the chord over here. And that chord makes the angle there, and it makes the same angle up there. Now we have to find 3 other angles equal to x. What are some other ones that we can get? R2, yes, yes, yes. Why is R2 going to be equal to x? What's the reason for that one? I'll get to M2 in a moment. I just want to follow the logic here. So R2 is equal to x, and the reason is exterior angle cyclic quad, because the cyclic quad is, let me use a nice thin pen so I don't get in the way of you guys, but here is the cyclic quad. Okay, now what is the one? We need one more, then we're going to finish the lesson for today. So we've got P1, we've got R2. Is there anything else that I am missing? Otherwise, I might have to call up the, we got that X over there. Sneakiness. Oh, look at the sneakiness here. I've just noticed something. If this is the center and it goes to the edge there, and this is the center and that is the edge there, what are those 2 things called? They are called radii, yes. And so what is the other angle that is going to be equal to x? Okay, so it's going to be S1 is equal to x, and that is going to be radii. Now I'm going to stop there for tonight because I don't want to do too much. This has to build gradually. But what we're definitely doing now is that the shapes that we're looking at are more complex, and we're starting to have to know the theorems in more detail. You'll also notice that when we come back to this question on Wednesday, we're going to talk about how do we know if SRMO is a cyclic quad. And so you can kind of see how we're including the old questions and then bringing in some new ones. Okay, but you've done well today.